We're going to go through annuities. And so an annuity is a situation where a person invests money into an account. So a person puts money into the bank account. And of course, because it's in a bank account, it gains interest. But then over time, what the investor does is make regular withdrawals from this account. And eventually all of the money gets withdrawn. So over time, you actually take out all the money from the account and the balance of the investment reaches zero. So when you look at an annuity on a sort of graphical representation, you can see that the balance, is pretty high at the beginning, whatever we've put in, but gradually over time, as we make these withdrawals, the balance is decreasing more and more. An annuity can actually be modeled exactly the same way as a reducing balance loan, but it's kind of like the scenarios in reverse, because what we're modeling is the amount of our own money that's in the bank rather than the amount of the bank's money that we have to pay back. And a common example of an annuity in real life is a superannuation fund. So often when people retire, they'll have saved up a lot of money in their superannuation fund, and then to pay for their living expenses in retirement, once they stop working, they actually take money out of the superannuation fund, which is really an annuity. Okay, this slide here, we've just got the way that you can set up annuities as a recurrence relation. So it's a similar looking formula to, or sort of a similar looking setup to our earlier recurrence relations. It's actually exactly the same as the reducing balance loans recurrence relation, just that what it's representing is a little bit different. So you can see we've got this 1 plus R over 100, that's our multiplying factor, and that'll usually be 1.0 something, that's going to account for the interest. And then there's minus P, which is the payment that we're taking out of the annuity. But as always, it's just important to remember that R is the interest rate per compounding period. So if it's monthly, we'll have to divide the annual rate by 12, for example. We can also use Finance Solver for annuities, which we'll do shortly in an example. And the important thing to remember is that with Finance Solver, as we have done with loans, when we think of money going to the bank, that's negative, but money coming from the bank to us is positive. Okay, so in an annuity, our initial value, because it's an investment, it goes into the bank, so that's a negative number. The payment is actually a payment we're taking out of the bank that's coming to us, so that's a positive number. And the future value is often going to be zero if we're waiting to see how long it'll take to pay out. Or if we haven't had it fully paid out yet, the future value will actually be positive because it's saying that the bank will still have to give us money, they will still owe us money. All right, let's get stuck into an example and see how it works out. So here we've got Jason investing $12,000 into an annuity to help fund his overseas holiday. So he's going to invest $12,000 at the start of his holiday and then gradually take money out of it to pay for his trip. His bank offers an interest rate of 4.8% per annum, compounding monthly. And Jason wants his annuity to give him monthly payments for 1 year. All right, so let's start to put some of that into Finance Solver. As we make our way through, we've got $12,000 invested, so that's our principal value. But that money is going to the bank, so it's negative $12,000. His bank offers an interest rate of 4.8%, so 4.8 is our interest rate. Remember, we don't have to adjust that manually ourselves. Finance Solver will do that. Compounding monthly, and we're talking about receiving monthly payments, so payments per year is also 12. The question's asking us for what payment he'll receive, so that PMT is going to stay blank. The number of time periods, well, he only wants this to last for 1 year, and he wants to make monthly withdrawals, so it'll be 12 months in 1 year. And the future value is going to be zero, because this annuity is only lasting 1 year, and at the end of that 1 year, the balance will be zero. So when we push PMT, we get our payment value of $1,026 per month. That's a positive number because remember that payment is going to be coming to Jason from the bank, and that's why it comes out as a positive number. So for part A, he's going to receive $1,026.19 each month. Part B then says use a recurrence relation to represent the value of his annuity. And we can do that now because we know the payment that's coming out each month. Okay, so that value will be in our recurrence relation. So remembering, first thing we need to know for the recurrence, or one important thing we need to know for the recurrence relation is the interest rate, but this time we do have to adjust it ourselves. So the monthly interest rate equals the annual interest rate divided by 12, which gives us 0.4%. The payment, we have our answer from part A. And so now that we know those two values, we can set up our recurrence relation. So the structure of the recurrence relation is Vn plus 1 equals, and in this bracket we've got 1 plus the rate over 100 times Vn, so that's the interest, and then minus the payment that's being made each month, which is the 1,026. And so we can write our final answer by actually calculating what's in that bracket, that 1 plus 0.4 over 100. That ends up being 1.004. And don't forget that a recurrence relation also has to state what the initial value is, and so V0 equals 12,000 because that was the initial amount invested. Okay, looking at a second example here. So now we've got Frankie, who has saved up money to set up an annuity while she's at university. She's saved $6,600 and would like to receive weekly payments of $55 to help with her expenses. If her bank has offered an interest rate of 5.1% compounding weekly, how many weekly payments will she receive from her annuity? It's kind of like saying, how long is this thing actually going to last before it runs out of money? So again, we can do this on Finance Solver. It's more of a long-term calculation rather than step-by-step. So it's not a recurrence relation question. It's a financial solver question. And again, let's just go through the numbers. So she's saved $6,600. So that's what she's going to put into her annuity. So that's the PV is negative 6,600. And it's negative because that's the money she'll put into the bank at the beginning. The payment she's going to receive from the bank is $55. That's a positive number for the payment. The payments per year and compounding periods per year, well, it was weekly, so that's 52 weeks in a year. N is the number we don't know. Okay, so we're going to be leaving N blank, but the interest rate is 5.1%. And the future value, well, if we're wanting to know how long it lasts until it runs out, the future value is actually 0. Okay, so with all that information put in there, we can then push the N button and see how many payments she's going to get. And she's going to get 127.7 payments, which really means in total she'll get 128 payments. Okay. And again, if you're filling in your notes now, make sure you write down the entries into Finance Solver, copy that into your notes. Don't just write the answer because later on that answer, you might forget where that's actually come from.